Alrighty, good people. Happy whatever day of the week it is. Today we are talking Intro to Matrices. Intro to Matrices is what you want to title your notes today. Remember, the perk of the video here is if at any point you need a little more time, feel free to pause me. Okay, the order of a matrix is going to be very important for a lot of things we do. We name the order of a matrix based on the number of rows and the number of columns. Okay, so when we're talking about these matrices, we use these brackets. We're going to fill them with different elements. We've got rows, so our rows go across. Like we could have row 1, row 2, row 3, so on and so forth. Our columns go up and down. So we could have column 1, column 2, so on and so forth, going up and down. Okay, rows by columns. That order is important. They cannot be interchangeable. Anytime you're talking about the order of the matrix, you're going to talk about the number of rows by the number of columns. Okay, so here let's determine the order of the matrices. Now, you decide as you're taking your notes, maybe you want to put in all these numbers. Maybe you put blanks. Ultimately, when we're just determining the order of the matrices, the numbers in our matrix are not as important as the number of rows and columns. So what I see happening here is we've got 2 rows listed first by the number of columns. Columns are the up, down. So I see 1, 2, 3, 4 columns. So we would call this a 2 by 4 matrix. 2 by 4 matrix. Okay, this next one here, starting with our rows. Looking at our rows, I see a 1, 2, 3. So we're talking about a 3 by something here. Then we're going to count our columns. 1, 2. So we would call this a 3 by 2 matrix. Rows by columns. Okay, sometimes it'll be important to identify the element in a matrix. Now, how we number these is important. So this here we've titled matrix A with that capital letter. In here, there could be a variety of numbers. Heck, we could even put in variables. In this first spot, we've got row 1, column 1. Okay. Here, we've got row 1. Goodness gracious, ignore me here. We've got row 1, column 2. Rows by columns. Row 1, column 2. Here, we've got row 1, column 3. So we use that lowercase a to talk about the elements in matrix A. Then that subscript notation is important here, so lower than the rest of what we've written, 13. Alrighty, down here we're into row 2, column 1, row 2, column 2, row 2, column 3. We could apply that to any size matrix. So we list the row number first, then the column number. So one of the things you could be asked to do with this would be to determine the value of element C13. So that capital letter C here, we've named the matrix C here. Okay, look in here, we're talking rows first. So that 1 tells us we're looking for the first row. That 3 tells us we're looking for the third column. Okay, so I go to row 1, column 3. That means element C13 is -9. Okay, we could add and subtract matrices. So in order to add or subtract matrices, they have to have the same dimensions. Okay, so these are what, 3 by 2s? That's the only way we could add or subtract things, is if they have the same number of rows and columns. Okay? So here we're adding A plus B, A plus B. So I started with a 3 by 2 for each of them. I'm going to end with a 3 by 2. Watch your signs here. Watch your order. Okay, so -2 plus -2. Here I'd have 1 plus 0. Here I'd have 1 plus 4. Here I'd have 5 plus 1. -5 plus -4. -5 plus -1. As you can see, lots of places where you could make just a silly mistake, lose a sign, look in the wrong spot. So take the time, double check your work here, make sure things ended up in the right spot. I believe things are looking good here. So we go ahead and simplify those. Nope, I said they were looking good. I lost a sign, didn't I? Let's see. -2 right here. To end up at -4 right there. Let's see, did everything else check out? Yep, looking good. So our final answer, we end up right here. Now this step right here, would I necessarily have to see it? No, you could do it in your head. However, you just saw that I made a silly mistake there. If I hadn't shown my work there, I wouldn't have known what happened to have gone wrong there. Here, I can see that work. I can say, oh, silly goose, I lost a sign. It should have been that -2. That's what went wrong. So in your best interest here to show your work. Alrighty, order matters when we're subtracting here. So taking matrix B and subtracting matrix A. Okay, so I need to take those B values first. From them, I'm subtracting the corresponding A value. Starting with the B value, subtracting the corresponding A value. Alrighty, looking here, double checking my work, seeing that things went in their correct spot, taking a few extra seconds here. It might save me a headache later on. So worth that time. Let's see, subtracting a negative, that's going to put me at 0. -1, 3, -4. Let's see, a +1 here, a +4 here. To end up at our final answer here. Alrighty, scalar multiplication. So scalar multiplication, we could have a number out front here. This S is our scalar. Then we have our elements happening here. I'm just going to make it a 2 by 2. Just throwing some numbers in there. So that scalar multiplication, we multiply that scalar value into each and every element. Okay, so we probably have numbers here, but we could have variables. After we multiply that scalar in, we'd be looking at something like this. Okay, so it still stays a 2 by 2. We just want to make sure that every element gets multiplied by that S with that scalar multiplication. Scalar multiplication. Alrighty, last thing here, we're going to keep on practicing subtracting or adding, as well as that scalar multiplication. So let's start here with that -2 into each term of A. -2 into each term of A. Watch your signs. Help me watch my signs. So -6 times that -2 scalar out front would put us at 12. 2 times -2, we'd have a -4 here. -2 times -5, +10. Same thing here. Okay, we are adding these together. Now I'm going to take 1/5 of each of the elements in matrix B. So here in matrix B, 1/5 of 25 would be 5. 1/5 of 50 would be 10. 1/5 of -5 would be -1. 1/5 of 60 would be 12. Okay, now we can go ahead and add these together, double check, yep, that's the operation happening right here. We can do it all at once in our head, or we can go ahead and show our work, never a bad idea, to see where we got these values from. To end in our 2x2 matrix of 17, 6, 9, and 22. Double check yourself, double check me real fast. Looks like that is checking out. So there is your intro to matrices. Finding the order of a matrix, determining elements within a matrix, adding, subtracting, and scalar multiplication. Be sure to reach out to your teacher if you have any questions, and I will catch you later.